Hi, good morning. Thanks for joining me here in my shop on February 11th. So I'm going to try to employ this device to check out how well this radio is working. I don't know if this radio works. I think it does. Not sure. So what I'm really trying to do here is a couple things at once, maybe even three things at once. I'm trying to gain some experience in actually using this. I've just finished restoring this to reasonable condition. It still has some problems in it, especially with the meter, but I think I can get away with using it. This is a B&K Model 960 transistor radio Analyst, and this is the transistor radio we're going to try to analyze with it. This is a dual band AM and shortwave receiver by Grundig, and I believe it's in working order. Made in Germany, but I'm not completely sure. Okay, that's interesting. Did I do that? I don't think I did that. So isn't there supposed to be Music Boy Transistor 200E. Well, it looks like you'd pop a 9-volt battery on there and be in business. Pretty rough shape. Some parts here are looking pretty rough. Okay, that's the challenge. What should I do here? Should I stick a 9-volt battery on there and see what happens? I think there once was a tube of batteries in here, and so someone, is it me, did this. I don't think it's me. This is I did it a long time ago. Okay, what I'm going to do, since I've got the model number here, is try to dig up a schematic right off the bat and just find out, is it a 9-volt? Is it supposed to run with 9 volts or so? The 200E. Okay. Well, that's as far as I'm getting right off the bat here. Okay, I did find schematic. There's lots of information about this radio. Quite a few pictures of it and the like. And I could see it does work off of 9 volts. So I'm going to use this, though, to generate the 9 volts. We're going to find out. I want to find out if this guy's working. So first I got to turn him on. Okay. Go. See, a little indicating light is on here. Now it's supposed to produce all the voltages you could ever want on your little radio. So this would be the 0 point, or ground point if you like, or negative. No, actually it's the positive side of things. Okay, positive side of things. And you get a it's too early in the morning for me here. And then I guess you get a progressively more negative voltage. So this would be the negative lead. You can see from the battery symbol here. Okay, I want to hook it up to the negative on the radio, and I don't want to get it wrong. I seem to have a great skill at getting these kinds of things backwards. So I have a battery here, which indicates the plus side is the big thing. Okay, I've got some clip leads that I've. Plus side is the big thing. Plus side is here. Now, is this really the right voltage? Earlier I did some tests and no, that's not. So we're going to pick through, use the voltmeter here to identify some a real 9-volt output, where it is. So let's see. Is this really true? Positive here. Let's try the 9. That's what I thought. It's much, much higher. 6, 4.5. So here we are, between the 4.5 and the 6. We'll go 4.5. That's going to give us 8 volts. That should be enough to operate the radio. Okay. Exactly why that is not correct, why the voltages don't match the panel, I'm not sure. But I'm not going to sweat over it. We're just going to use what we can. And I'm going to switch this. Like this, so the black one is on the more negative lead. Okay. Now this radio might come to life as soon as I do this. Let's see. So this is off. This meter is set on the 150 milliamp scale here. It's going to read the draw from the radio. So let's connect it up. Nothing happening, of course. So I haven't turned it on. Okay. Let's see if I can just fix this other camera view so we get a better picture here. What's going on? I have the feeling it's not going to stay up there. Yeah, that's good enough. Okay, switch on. Okay, so the meter goes up. Very good. Now on the 15 scale, come and go. It was here. .150 scale. This is about 150, 150. I think we'll go just about full scale if I do this. There we go. So on the 15 milliamp scale, we're reading about 10, 11, 12 milliamps. Okay, let's tune this radio. What band is it on? Good question. It's on shortwave. Let's put it on medium wave. You can see the volume effect on the overall power draw. A little wee bit. Okay, tune around. We're at the high frequency end of the AM band. Get some stations. It's definitely receiving. Oh, this radio's working really well. We're done. So what I've discovered is the power supply coming out of here has no hum. You don't hear a hum coming out of the radio. That's good. And I can read the overall power draw on the radio here. Let's turn it up and just watch what happens there. So this particular station, a lot of radios in my shop can pick this French station up. Some cannot. So this is actually very good. just happen to have this radio in the right angle for this station. Dirty volume control, I think. Okay, so I notice the oscillator's on here. Let's just make sure. I like that. Lead to an external antenna, not very good for AM radio at all. .640, good. So 640 really should be about there. Now that's probably 680 we're hearing now. 680 should be there. Okay, let's give the shortwave a shot here. I imagine you need an antenna on here, so I'm going to clip on outdoor antenna for what it's worth. So we'd expect to pick stuff up in this range here at this time of day. What's this? Tone? Tone. .12 megahertz. 13 at the top. That's it. So I'm going to just check the antenna and make sure the antenna is switched on down there. Well, not terribly impressive as a receiver, but down here in my shop things are very difficult. The time of day is bad for shortwave too, so this may not be a fair test of the radio, but it does work, that's for sure. Does it work well? Well, let's see, the first indication is the amount of current that's drawing. So this is up a little over 10 milliamps. Smaller radios should be drawing 4, 5, or 6 milliamps, 8 milliamps, something like that from what I understand. This is not so small physically. Drawing this kind of power out of a 9-volt battery, I couldn't tell you how long it would last. I don't think it would last as long as you'd want. I'm pretty sure in here there was a tube full of batteries. You need 6 batteries to get 9 volts. So you need a parallel tube, two rows of 3 batteries. 1, 2, 3. So I'm pretty sure that's what was sitting in here at one time. Where it's gone, I don't know. Now, we're going to do some more with this radio and this guy here. The next thing to do would be to, for instance, if we're pretending this radio doesn't work, there's some kind of adjustment here. This must be there. I can put that up easy. Tuner parts in here. I see all the adjustments are waxed up. You can see the wax and all here. This is maybe not the best radio to experiment with. The next thing to do anyway would be to feed the audio signal into the audio circuits, an audio test signal out of this box. And the idea is you feed it to the base of the transistors involved. And the result of that is, if the radio is working, you hear it. It's a 2000 hertz tone. You hear it come out of the speaker. And you see a pickup on the draw on the radio, so that this current meter would go up a little bit. Of course, if you hear it coming out of the speaker, that should be pretty satisfactory. Then you would work your way back in the circuit, touching the base of transistors along the way, until you found something that didn't work. Now, this guy's working. May not be working well, which is actually a worse problem. It's got a big electrolytic here, it's got an electrolytic there, there. The transistors look like germanium transistors to me. They're large metal cans, and it looks like they're plugged into sockets. So, I mean, that makes pulling them out easy. Pull it out, put it in. There's one here, here. I don't think it said anywhere how many transistors are in here. Let's see, 1, 2. This may be one here. 3 maybe. 4, 5. That's it. could be the case. Just 5 transistors. And I probably missed a couple. The thing about them is getting at the base lead is essentially not possible because they're plugged in to these sockets. You see right down in there. And there's no lead exposure anywhere. There's all kinds of parts nearby, but if we just playing a guessing game as to what part is hooked up to any one of the leads on the transistor. I don't want to do that. Yeah, I think this is probably not the best radio to fool around with. I mean, the main thing is that it works. Fooling around means it may not work when I'm done. So, so I'm going to get another radio. I mean, we'll just try another radio. Okay, I grabbed another radio off my shelf here. Cover your ears. This is an AM FM radio. It's in FM mode right now.
Get Up and Go show with Gail and Steve Bradley in the mornings. Lamb Christian hits at night. Here's the new one by Jeff Catto on Life 100.3. This is the brothers and the sisters out around.
That's working pretty good. Don't have it broken except for this control. Let's flip to AM. Here comes Peanut. What's up there, Peanut? Okay, it's receiving. Hang on there.
Countryside to Mainfield might as well be closed. You might want to find another way around here. It's busy. It's been jammed up all morning because of this crash with only 2 tractor trailers. Downtown Queens Park close to College to you behind the curtains and inside the wherever you
Well, it's another working radio. Except for that dirty control. Why don't we just fix that? Yes, what's up, Peanut? You're lacking attention this morning? Is that what it is? Volt battery. This one is a much newer radio. It's not as old as that last one. Has many transistors in it. Oh, come on, Peanut. So, looking for a place I can spray a little cleaner. Oh my gosh, listen to him. Just, can you wait like 2 minutes? Okay, 2 minutes. Okay, he ran out the door. So to spray this right into the control, get into where the wiper is. Yikes. I'm going to try going right through a rivet hole here. Got it. Fixed another radio. That's 2. Wow. Okay. Peanut. Okay. I'll spend some time with you. Okay? Yeah. It's okay. Okay. Work my way through my limited supply of small transistor radios. It's a Sanyo. 6 transistors. Okay, there's probably no battery in it. Case is cracking. There's a grip there, it's broken free, so this is very fragile now. It's all cracked through here. That's debris from a battery. Okay, we got one here. Does it work? So it's going to be 2 batteries. That's going to be 3 volts. So let's see if I can get 3 volts. I don't think it needs to be all that precise. In fact, I think these transistor radios can work with it. A range of voltages. It's the model 6C337. Transistor superhet. IF 455. 2 penlight batteries, 3 volts. Okay, so we need our voltmeter here. So we get 3 volts from. What about the 3? 3 produces 5. What about the 1.5? 1 point, that's the smallest it goes. That's 4 volts. I don't think that's going to be a problem. Make the radio a little louder if it works. So we'll go here. So I can see that these contacts are continuous, so this is the real into the radio, badly corroded. So the plus goes here. Okay, switches off. The whole radio is ready to fall out. Contact this will be. Okay, the little radio. Don't know if I've ever heard this one operate. Here we go. Oh, 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 oh. Turn it off again. Oh my gosh. So we're on the 15 milliamp. And it went all the way over. That's not a particularly good sign. That doesn't mean there's a problem, but that's quite a draw again on a little radio like this. 1, 2, 3, 4, 5 transistors. Okay, well, let's try it again. We'll assume that's the proper current. We hear nothing, so we have a broken radio here. I would guess that current draw is indicating a problem itself. Again, all the components, the transistors are pushed down tight to the board, so really you'd have to take this out and troubleshoot from the backside. Speaker's going to stay behind. Controls are here, so we kind of have to. two little nuts down there that would have to be removed. Not sure I really want to work on this. I'm more interested in getting some experience with that. Okay, well, you know what? I've got one more radio. Let's try one more. So I do have a nice vacuum tube radio waiting. I'm going to close this guy up. And you know, what's that worth anyway? Can't be worth much of anything. This one's a little different though. Look at this. Lovely leather case. Phillips. So it's kind of bolted in there. It's another working radio. Just an AM radio, and it has the frequency scale here, and it has the meter scale up on top. Where's all the parts? Install mercury. Turn this down. Turn it right off. Install mercury batteries this way up. Penlight batteries with contact point this way. Mercury batteries he's talking about. These batteries aren't that old. I put them in myself. Another radio that's in working condition. What am I going to do to it? I don't think I should do anything to it. It's a very unusual headphone plug there. It's in lovely shape. Well, we could check the current draw on this. Could do that. How can we do that? Now, are all these batteries in series? They don't look like it. The way they're put in, we're not going to be able to tell. Yeah, it's not going to be easy to figure out. Okay, too bad. I'm not going to go anywhere with this one because it's in working order, and I'd like to keep it that way. We're not going to fiddle with this one. Well, I have one more radio. This is my own transistor radio from when I was a kid. going to have to go hunt it down. I think this Philips one is very nice. This one here. Very good. And the reason it's nice, it's inside a leather case, which is in pretty good shape too. So I'm going to leave well enough alone. I've certainly learned my lesson about stuff like that. I'm going to get one more transistor radio. One more. Okay, one last radio here. Now this was my radio when I was a teenager. I was very excited to get this radio. As far as I know, it works. 2 batteries. Okay. See the wires coming out this end, so that'll be negative and positive. Okay, it's switched off. Let me just adjust the lights here a little bit. Kind of see the pointer. There we go. No movement, that's good. Switch on. Oh, it's even more than the last radio. Okay, let's clean up the volume control here. First off. These rivets that are in here are not hollow. I'll try shooting it in past that rotating shaft there. Good luck. Doesn't take much to ooh, that's a lot. Got a little in there somehow. Okay, put the power back on. Okay, sounds like it's working. Tune it. See if we can get something. Fix it. Okay, there we are, another working radio. It's really fixed it again, just the volume control. Well, I don't think there's really anything here for me to do that wouldn't be just full of risk with a little benefit again. So, interesting thing is, a small radio drawing a lot of power. One little I know, because I don't know a lot, a more reasonable power draw on a radio like this is around 4 milliamps, not 15. But I don't know for sure. I don't know. Okay, that's it. That's all I'm doing. Tomorrow we're back to tube radios. I'm going to set this aside until the day I really need it. I find a good project to work on, something like that. Great. Okay. That's it. Thanks a lot for watching.